This is the post-analysis of Typhoon Gaemi. Typhoon Gaemi had intensified and strengthened from being a weak tropical storm near the Philippines power region, forming quite far west in the Pacific region, and had then intensified and moved northwest towards Taiwan. It was during the monsoon season, and it had performed a very rare loop. It's called a mountain-induced steering disruption, and when this happens, usually the central mountain range in Taiwan, at 3,900 meters in height, acts as a physical barrier, and that disrupts the typhoon's low to mid-level circulation. As the typhoon approaches, these mountains create a differential friction, slowing the winds on the western side while maintaining stronger flow on the eastern side of the island. This can deflect the track unexpectedly, typically creating a loop. This loop has been seen in Shirley 1960, Mary 65, Sarah 89, Polly 92, Haitang 05, Krosa 07, and Sinlaku 08. The system had rapidly intensified with rapid intensification of 65 miles per hour in 24 hours, and the maximum size was roughly 641 nautical miles in the cloud-to-cloud cover. It was fairly sizable, and the monsoonal moisture had increased that rain band width and size, especially given that it had a small eye, only of 4.5 to 5 miles width during peak intensity. This small eye was very unstable and quickly was replaced during a merger eyewall replacement cycle, or MERC, where an outer concentric ring merged with the inner, and his eyewall depleted, however, quickly during the loop as it made landfall in Taiwan. Typhoon assessment. So for Typhoon Gaemi, we used Schlomer's equation, a physical model, to obtain 898 millibars. We applied to estimate a central pressure based on wind radius and decay constant, P. We relied on spatial wind distribution and confirmed reasonable values for environmental pressures at monsoonal around 1000 millibars. And we used Schlomer's equation, and it's robust, but it has to be carefully calibrated. We also used a regression based, which obtained 885 millibars, and is derived from empirical relationships between the wind speeds and the central pressure, and this can usually underestimate. And then we had to do some confidence weighting with Schlomer's equation at 80% confidence whilst the regression at 60%, and we balanced that with physical modelling and empirical trends. The final output was 895 millibars, and we reduced this from an initial estimate at 902 millibars, and we had to obtain, using alternative methods as well, using CKZ, Dvorak and extrapolation.